Hey, how's it going? This is Mr. Branch. For today's lesson, we're going to work on proving two lines are parallel. So what that means is if I have these two lines that are cut by a transversal, we're going to figure out multiple ways, that we can prove these two lines are parallel. Before we get going on proving lines are parallel, we need to remember the postulates and theorems that we've learned previously that start with if the two lines are parallel. So the postulates and theorem I'm talking about is the first one is the same side interior angle postulate. So what the same side interior angle postulate tells us is that if these two lines are parallel, then same side interior angles, angles that are on the inside of the lines that are on the same side of the transversal, will add up to 180. So that means that this angle and that angle add up to 180, or they are supplementary. Also, the angles on this side, which are same side interior angles, they too will add up to 180, or they are supplementary. So let's say this angle is 110, then that angle is going to be 70. If this angle is 120, then that angle is going to be 60, because they're going to add to 110. So that is our only supplementary angle postulate. The other theorems are dealing with angle congruency. The first one is the alternate interior angle theorem. And what that one states is that if two lines are parallel, if these two lines are parallel, then alternate interior angles are congruent. So here's one alternate interior angle, and alternate means it crosses over the transversal, so it'd be congruent to that alternate interior angle. The other set of alternate interior angles occur on the other side of the transversal. So if these two lines are parallel, then this angle is congruent to that angle, and this angle is congruent to that angle. That's the alternate interior angle theorem. The alternate exterior angle theorem tells us that if these two lines are parallel, then alternating exterior angles are congruent. So this angle is congruent to that angle. They're both on the outside of the lines and opposite sides of the transversal. And the other set of alternate exterior angles are these two. So those two are congruent given the alternate exterior angle theorem. The last theorem is the corresponding angles theorem. So corresponding angles are angles that are in the same location at the intersection. So we have the top right angle, we'll give this one a star, is at the same location as that one. So the corresponding angles theorem tells us that if these two lines are parallel, then these two angles are congruent. Bottom right, we'll go with an asterisk. Those two are congruent because they're corresponding angles. So if these two lines are parallel, then those two angles are congruent. Bottom left corner, we'll go smiley face. So the two smiley face angles are congruent. And the last set are the top left corner. Running out of stars here, we'll go plus sign. So plus sign, plus sign. So these two angles are congruent because they are corresponding angles. And what you'll notice is that these single arcs, because the vertical angle theorem, are congruent. Same with these double arcs, and that's something we know previously. And you'll see that there are actually two unique angles when we have two parallel lines cut by a transversal. There's really only two unique angles, and that's something that we've seen over time. Well, moving on from here, we are not going to start with two lines being parallel, but instead we are going to prove these two lines being parallel. And the way we're going to do that is using corresponding angles, alternate exterior angles, alternate interior angles, and same side interior angles. There's actually a set of converses. Now, converse is the reverse of an if-then statement, so what was the original hypothesis is going to be the conclusion of these converses. The first converse we're going to look at is the converse of the same side interior angle postulate. What this converse tells us is if two lines and a transversal form same side interior angles that are supplementary means they add to 180, then the two lines are parallel. So you'll see that our conclusion here was the hypothesis of our original postulate and theorems. So we're trying to prove these lines are parallel. And the way we're going about that is by showing these two angles are supplementary. So if I can somehow show that x plus y equals 180, then I will have shown that the same side interior angles are supplementary, which in turn proves these two lines are parallel. Now there's another set of same side interior angles here. It's these ones down here. And let's say this one is angle, got a value of A, and this one has a value of B, and that marker has run out. So we'll switch over to this one, A and B. Then if A plus B equals 180, then I will have also shown A and B are supplementary, thus proving those two lines are parallel. So that's the converse of the same side interior angle postulate. The next converse we're going to look at is the converse of corresponding angles. So if you remember that corresponding angles are angles in the same location. So the converse of the corresponding angle theorem tells us if two lines in a transversal form corresponding angles that are congruent, then the two lines are parallel. Once again, our conclusion is the two lines are parallel. So if I could somehow show that this angle is congruent to that angle, then I will have, in fact, proved those two lines are parallel by the converse of the corresponding angles theorem. If I could show that these two angles are congruent, then I will have shown that corresponding angles are congruent, thus these two lines are parallel by the converse of the corresponding angle theorem. And the same can be said if I can show that these two angles are congruent to each other and these two angles are congruent to each other. So if I could show any set of corresponding angles are congruent, so I just got to show one set, so I just show these ones are congruent, then I can conclude that the two lines are parallel. The next converse we're going to look at is the converse of the alternate interior angle theorem. So if you remember, alternate interior angles are angles that are on the inside of the two lines. Sorry, they're not parallel yet. They are the angles on the inside of the two lines and on opposite sides of the transversal. So this is one angle. The alternate interior angle to that angle is this angle. So if I can show that these two angles are congruent, then I can conclude that the two lines are parallel. The other set of alternate interior angles are these two. If I can show that these two angles are congruent, then I can conclude that the two lines are parallel. That is the converse of the alternate interior angle theorem. The last converse we are going to look at is the converse of the alternate exterior angle theorem. Now, exterior angles are on the outside of the lines. So here's our two lines. Exterior angles are on the outside. There's two sets. There's these two and these two. So if I could somehow show that those two angles are congruent, then I can conclude that these two lines are parallel. Likewise, if I can show that these two angles are congruent, then I can conclude that these two lines are parallel. So there is a couple of different problem types that we will come across when using these converses besides just a normal geometric proof. The first one is like this example. The question is, are these lines parallel? Well, if I look at 65 and 110, they aren't any of those special angle pairs we talked about. They're not alternate interiors because that'd be 65 in this one. They aren't alternate exteriors because that'd be 110 in this one. They aren't corresponding because 65 would correspond to that one. 110 corresponds to this one. They're not same side interior. So what we need to do is we need to figure out some angles that might match up together to utilize one of our converses. So one thing we can use is if this angle is 110, we know that this angle right here and this angle right here form a linear pair, which means they add up to 180. So if this angle is x, we know that 110 plus x equals 180 because they form a linear pair. So if I subtract 110 from both sides, I figure out that x equals 70, which means this angle right here, which I've called x, is in fact 70. Okay? Now, are 70 and 65 equal? Nope. So since 70 and 65 are not equal, I cannot apply the converse of the corresponding angle theorem. See, these 70 and 65 are corresponding angles. They're not equal, so I can't apply the converse, which means these lines are not parallel. They are not parallel. A similar example looks like this one, where we have 137 and 43. Now, once again, these are not any of the special angles that we have. They're not any special angle pairs. 43 does not correspond to 137. They are not alternate interior. They are not alternate exterior. They are not same side interior. So I got to figure out a way to get 137 or 43 to a spot where they would be corresponding, same side interior, or alternate exterior. Now, one theorem that we know from previous chapters is the vertical angle theorem, which tells us that when two lines intersect, the angles that are across the intersection from each other are congruent. So if this angle is 137, so is that angle. Now if I look at 43 and 137, if I can show that they are supplementary, which means they add up to 180, then I can use the converse of the same side interior angle postulate to prove that those two lines are parallel. Now if you add 43 to 137, you will in fact see that they do add up to 180, which means these lines are in fact parallel. So we can conclude those lines are parallel by the converse of the same side interior angle postulate. Now, example 1 and 2 are a little simpler than 3 and 4. Example 3 and 4, not only do they involve the application of the converses, but they also involve some one-step algebra. So example 3 is asking what value of x will result in the lines being parallel. So if I look at these two angles they gave me, 4x minus 30 and 2x plus 20, I in fact see that they are alternate interior angles. So I'm going to apply the converse of the alternate interior angle theorem, which says if these two angles are congruent, then the lines are parallel. So I'm going to start there by saying that those two angles are congruent. 4x minus 30 equals 2x plus 20. So by saying they're congruent, I'm saying that I'm finding the value of x that makes the lines parallel. So I'm applying the converse of the alternate interior angle theorem. So the first step in solving this equation is to add 30 to both sides. So then you get 4x equals 2x plus 50. Next step is to subtract 2x from both sides. And you'll get 2x equals 50. The last step for solving for x is divide by 2. And we'll get x equals 25. So what this is saying is that if x is 25, then we can conclude those two lines are parallel. Now to make sure we are correct, we can plug in 25 into this equation and figure out what its value is. So 4 times 25 minus 30. 4 times 25 is 100, minus 30 equals 70. So it's saying that this angle right here is a 70-degree angle. We can also plug in 25 right here. 2 times 25 plus 20. 2 times 25 is 50, plus 20 also equals 70. So when x is 25, these two angles are in fact both 70, so they are equal. So if alternate exterior angles are congruent, then we can conclude the lines are parallel using the converse of the alternate exterior angle theorem. Though what I did at the end is more or less a check to make sure that when I solve for x equals 25 that I did in fact find the right value. The last example that we will come across in our assessment, in our homeworks, in our follow-through activities is one that might look like this. It's very similar to example 3, except now instead of having alternate interior angles, we have alternate exterior angles. And we could look at this and say, oh, we got corresponding angles, or oh, we got same side interior angles, and it's all just an application of each of the converses. But here we have alternate exterior angles. So to show or to find the value of x that will result in these lines being parallel, I'm gonna have to assume that 5x minus 20 is equal to 4x plus 10. So I'm going to start there. 5x minus 20 equals 4x plus 10. So now I need to find the x value that makes the lines parallel. So to do so, I'm going to first add 20 to both sides. We'll end up with 5x, equals 4x plus 30. That's like 36, plus 30. My next step is to subtract 4x from both sides. 5x minus 4x is equal to x. which means I've figured out what value of x will lead to these lines being parallel. And once again, I can check my answer by plugging in 30 for x. 4 times 30 is 120, plus 10 makes 130. Same thing over here. 5 times 30 minus 20. 5 times 30 is 150, minus 20 is 130. So I've in fact shown that when x is 30, the alternate exterior angles are congruent. And if the transversal intersects the two lines in such a way that the alternate exterior angles are congruent, well then we can conclude that the lines are parallel. So in fact, when x is 30, the lines will be parallel. Those are all the examples I have for today, so thank you for watching the video. If you have any questions, any of my students, feel free to email me. Anybody else who are watching this video, just drop a question in the comments and I will answer it for you. Thank you. Have a great day if you want to.